Welcome to the flight levels. Lots of people have been talking about advisory vertical guidance on approaches, commonly called +V. There's been a lot of confusion around how to use it, what it even is, and more importantly, how not to use it. Here we go. First off, we have different kinds of instrument approach procedures. The gold standard and the best thing that we have currently are precision approaches, which include glide slopes. Whether this is an LPV or an ILS, this gets you all the way down to decision altitude and provides you guaranteed obstacle clearance all the way down to that decision altitude. In the absence of a precision approach, we have non-precision approaches, and these give you step-down fixes with altitudes as well as a minimum descent altitude. So, as we fly non-precision approaches, there are two styles of flying that we can do. The old style is the dive and drive method, and this is where as soon as you have an opportunity to go down to a lower altitude, you go down as quickly as reasonable, and then you level off at that next lowest altitude. The perk of this method is that the whole point of flying any instrument approach procedure is to get below a supposed cloud deck and to see the runway environment so you can ultimately land. Using the dive and drive method, you get down to the lowest altitude possible as soon as possible, and therefore you have the longest opportunity at this minimum altitude to increase your chances of seeing the runway environment. Now, the downside of this is the dive and drive method requires a lot of configuration changes, power adjustments, and you need to pay extra attention to make sure that you level off at each minimum altitude along each segment of the approach. Years ago, the FAA and the National Transportation Safety Board began pushing what's called Continuous Descent Final Approach, or commonly called CDFA. And this is a wonderful concept. The benefits of it is once you pass the final approach fix, you essentially do a single configuration change of the airplane. You set the power and you set essentially a constant rate of descent. And as long as you want to continue descending, you would continue on this continuous descent all the way down to the concrete. And the great part about this is it doesn't require configuration changes. It doesn't require power adjustments. You just set it and you're continuous. Now, the downside of continuous descent final approach is that with that goal of seeing the runway environment and ultimately landing, you end up at your minimum descent altitude at a very small amount of time. So your chances of seeing the runway environment may be reduced if that moment that you get down to the minimum descent altitude is also the moment you have to execute your missed approach. So there are pros and cons to both dive and drive and continuous descent final approach. Now, you might be saying, well, Joe, I fly an old airplane with old avionics. How am I supposed to do continuous descent final approach? Well, actually, you can do it there too. You don't need any fancy GPS-ness. All you need to do is figure out what angle you need to descend at between your final approach fix and the runway. And basically, based on your ground speed, you can figure out what rate of descent you need to descend at. Now, the key to doing this, whether in a fancy GPS-equipped plane or a conventional style avionics plane, is you still need to comply with all of your minimum altitudes along your non-precision approach. You don't get to just completely ignore those and continue descending. We're just following this concept of doing a continuous descent all the way down. At the same time, having a fancy gee-whiz GPS calculate your continuous descent angle is a pretty nice feature. And the way it works is the computer basically has two anchor points. The first one is essentially at your final approach fix at the minimum altitude where you would cross the final approach fix. And then down at the bottom anchor point, you would have the runway threshold at the threshold crossing height. Now, one of the requirements to have this advisory guidance on your GPS is you must have Wide Area Augmentation System, or waas. So early Garmin units such as the Garmin 430, 530 that don't have waas, and also some of the earlier G1000s without waas, are not capable of providing this advisory glide slope because you basically need to have an accurate altitude readout, which waas provides. Other circumstances where you will not have the +V guidance is if your approach that you're using already has LPV minimums, then you already have as good as it gets. There's no reason to not use that. If LPV is available, that's what you're going to get. The other instance that you're not going to have +V is if your approach plate is circling only. So for example, if it is the RNAV approach -echo, meaning it's not assigned to a particular runway, it cannot provide +V because, as we talked about, it needs that bottom anchor point of a specific runway's threshold. And if that doesn't exist, there's nowhere for it to put this advisory glide slope. So we've talked about where +V will not exist. Let's cover where it will exist. As we've covered, your hardware in your GPS needs to have Wide Area Augmentation, or waas. It also needs to pass its own integrity of Satellite-Based Augmentation System, or SBAS. If for whatever reason that integrity is not meeting those requirements, it will automatically not display the +V. Next, the approach you're using, like we talked about, needs to have either LP, which is localizer performance, or LNAV minimums. Now, I bring this up because in recent memory, everybody has been calling this LNAV+V, and it's important to know that +V can also be applied to LP approaches, which is localizer performance. The difference between the two is that localizer performance ramps down in how wide the CDI deflection is, just like an LPV approach, whereas LNAV approaches are a fixed 0.3 of a mile either side of centerline. Great. So now you have the equipment in the plane, you have the SBAS integrity, you are on a non-precision approach to a specific runway. So let's talk about how this goes. So do you need to tell the controller that you're going to be following a +V vertical guidance? No, they don't care. Remember, you are just cleared for a specific approach, and then the controller knows what airspace to block to protect you. What you do in that protected airspace is totally your business. What minimums you fly, what approach category, that's all up to you. The controller does not care, so don't waste your time telling them. As you fly toward the final approach fix, you need to look at your GPS screen. Specifically, you need to see, is it saying just LNAV, or does it say LNAV+V? Now, this display happens automatically. There's no input required from you. It's going to use the criteria that we've just covered to decide if all of the eligibility for +V exists. And if it does, it's going to have that +V displayed on there. Now, if you're using your autopilot, this is the point where you're going to press the approach button so that you can arm glide slope tracking. You're going to follow your step down altitudes all the way through your final approach fix. And then you're going to capture the depicted glide slope just like when you're flying an LPV approach. It looks exactly the same to you as well as to the autopilot. Now, here is a really important discussion we need to have. Let's talk about different pitch control modes in digital autopilots. So, depending on which mode you're in, your autopilot can either hold a specific pitch attitude, it can hold a specific altitude. It can also perform a flight level change or a change in altitude based on a foot per minute climb or descent that you set. It can also perform a flight level change based on an indicated airspeed that you have set, or it can also follow a glide slope. And the really important thing to remember is that flight level changes can automatically terminate upon reaching the altitude that you set in the altitude pre-select box. When you have the autopilot following a glide slope, however, it will follow that glide slope indefinitely. It will never automatically switch out of following a glide slope until you manually switch one of these pitch control modes. Now, the autopilot stays on that glide slope indefinitely for good reason. Can you imagine flying an actual IMC approach, following an ILS, and then unexpectedly the autopilot levels off at your decision altitude when the runway is right there? That I sure as heck wouldn't want that. So whether you're following a ILS glide slope, an LPV glide slope, or one of these +V glide slopes, the autopilot behaves exactly the same. It is consistent. So this means that when you are using an autopilot to follow an advisory glide path or a +V, you must manually monitor your altitude relative to the minimum descent altitude. And upon reaching the minimum descent altitude, you have a couple options. If you are able to comply with all the requirements of 91.175, you can continue following the advisory glide path below MDA, understanding that just like any approach between the MDA and the runway, there are zero assurances of obstacle clearance. That is completely up to you. And that also includes below decision altitudes. Also, you do have the prerogative to enable altitude hold and continue flying at that minimum descent altitude all the way to the missed approach point. However, if you do this, you are very unlikely to be able to descend using normal rates of descent and normal maneuvers onto that runway. So what you really should be doing is, if you're following one of these +V advisory glide slopes, is once you reach MDA, if you cannot see the runway environment and fulfill all of 91.175, you should treat it like a decision altitude. Now, like I've said, the advisory glide path or +V is a wonderful feature. And in my experience with the avionics that I had in my plane, Garmin very thoroughly covers exactly the considerations you need to have when you use it. Let's take a look. So we have this note. Some RNAV GPS approaches provide a vertical descent angle as an aid in flying a stabilized approach. Great. These approaches are not considered approaches with vertical guidance. Approaches that are enunciated on the HSI as LNAV or LNAV+V are considered non-precision approaches and are flown to an MDA even though vertical glide path information may be provided. On another place, warning, when flying an LNAV approach with vertical descent angle with the autopilot coupled, the aircraft will not level off at the MDA even if the MDA is set in the altitude pre-select. Just like we've talked about, autopilot will continue following a glide slope indefinitely until you manually switch pitch modes. Now, here's some arguments that I've been reading a lot about. And one of them is that Garmin should have designed these advisory things and their autopilots to automatically level off at the minimum descent altitude. Well, my response to that is that completely defeats the point of continuous descent on final approach. And that would not be consistent with how autopilots follow any glide slope. Garmin is consistent by having the autopilot behave this way, whether you're flying an ILS, an LPV, or one of these advisory ones. It is consistent. Further, even if they wanted to make it level off at MDA, the MDA changes upon so many factors. The MDA is different depending on which approach category you're using. It changes based on some NOTAMs, and the MDA can also be raised as a result of cold temperature adjustments. So to assume that Garmin avionics are going to be able to adjust for all that is not reasonable. The next argument I've seen is like, oh, well, you know, pilots assume that if they see a glide slope, then that means they're safe. And this isn't the case even on ILSs and LPVs. Like we've talked about, when you go below decision altitude, there is no assurance of obstacle clearance. So applying that same logic to MDAs, again, the FAA and Garmin are being consistent. And lastly, a lot of people are arguing that autopilot logic is confusing. And sorry to beat a dead horse here, but Garmin has been consistent. In approach mode, where the plane is following a glide path, it's going to do that indefinitely until you manually change pitch modes. And this is the same whether you're flying a $50 million Gulfstream or a $50,000 Cessna 172. The pilot is the one responsible for not going below decision altitude or minimum descent altitude. Great, what do you guys think? I hope I clarified some of the misconceptions about how advisory vertical guidance, or +V, works. Let me know in the comments if you still think that Garmin did a terrible job of designing this and they are just setting up pilots to fail. On the other hand, do you guys think that Garmin made a great product and you guys use it on a regular basis? All right. We'll see you guys next week. Be sure to check out flight-levels.com. And remember, don't just fly, climb to the flight levels.